card. My sister, my cousin, and my mom. Okay. Light for most creatures is their means of getting around. It helps them see what they're approaching, what's approaching them, or simply just what's around them. But what happens when light just isn't around to be a helping factor? It's a tough one, but luckily I've got the answer. A few creatures have evolved an impressive technique that uses sound instead of light to create a picture of its surroundings, allowing it to travel through dark environments above and underwater. This technique is called echolocation, and it's a vital tool of survival for our nocturnal and underwater friends. Today, I will be informing you on echolocation as a whole by covering the science of echolocation, the creatures that use it, and how echolocation differentiates between species. I've always been a geek when it comes to this type of thing, so it's kind of my passion. My love for nature, plus the research I put into it, has made me a valuable source for information on echolocation. My speech here today will ensure that those who hear it will gain the luxury of going out into nature and knowing in better depth what's going on in the environments around them when that light switch turns off. Now that we have covered the main points of my speech, let's go into my first topic, the science of echolocation. The science of echolocation is quite fascinating. Creatures emit a series of high-pitched sounds that are too high for our ears to detect. This is called ultrasound. Okay? Then sound returns as an echo carrying information that then the creature can analyze and know what their sound has hit. I found this to be a neat representation of how an echo works. Sound travels as a compression wave, and as you can see, the sound leaves its point and returns to its point once it makes contact with an object, alive or non-living. And that's essentially how it works. Through these echoes, creatures are able to figure out the distance, the size, and the movement of the object. For instance, the speed in which the echo returns indicates the distance of the object at hand. The intensity of the echo indicates the size. If it returns higher intensity, that means it's bigger. If it's in lower intensity, that means it's smaller. The frequency of the echo indicates the movement. If it returns with a higher pitch, that indicates that it's moving closer. If it returns with a lower pitch, of course it means it's moving further. It's pretty much opposite oriented, and it's very interesting. Now that we understand the science behind echolocation, let's go into the animals that use it. Famously known around the world to use it is the bat. But what many people fail to realize is that other creatures such as dolphins and even birds also incorporate echolocation into their lifestyles to thrive and survive in their domains. The bat is first to mind when talking about night sky domination. Its ability to echolocate is what puts it at the top and makes it dominant in comparison to its prey. It's like a cheat code. He can see without relying on its eyes. He then uses this ability to find food, avoid obstacles, and prey, including predators, including owls. The dolphin also uses echolocation in its environments because it can become dark and murky, especially the deeper they swim. So echolocation is essential for a dolphin's lifestyle. Without it, it would be like swimming blindly. And finally, aside from bats and dolphins, a bird called the oil bird also uses echolocation. This bird is located in caves and tunnels, so echolocation definitely comes in handy in regards to traveling in pure darkness. It's pretty crazy how a bird can learn to echolocate, and according to SCI's shows Hank Green, a bird that thinks it's a bat, this is because of something called convergent evolution. This is when two different animals face two similar pressures caused by natural selection, which result in them having similar traits. So that's pretty cool. Now that you understand the animals that use echolocation, let's talk about how it's different within each animal. Echolocation, although it's used in various animals, and it relies basically on the same concept, it's different in each one. Starting off with the bat, BBC Earth Unplugged, what is echolocation, states that a bat has special muscles in the back of its throat that allows it to emit ultrasonic clicks up to 190 times per second. It also has unique folds in its ear that helps it dissect and analyze all the information coming from the echoes thoroughly and to the point. He then turns this information into finding food, again avoiding obstacles and predators. The dolphin actually has something called the melon in its head. The melon amplifies and sends waves out into the ocean. This comes back as an echo and is absorbed by the jaw and forehead, which work like antenna. The brain then turns this information into essential information for finding food, avoiding obstacles in the water, and predators, which in this case, unfortunately, is us. The oil bird has a much less complex use for echolocation. The bird's not in much danger, and according to birdsoftheworld.org, the IUCN classifies it as least concern because it's so high above the ground that it's not really around any predators. So the oil bird uses echolocation in a much simpler form, which is just to get around. But it's still very interesting that a bird can echolocate. So finally, now that we understand how echolocation is different between different species, let's gather what we learned. Today we have learned the ins and outs of echolocation by going over the topics that are most important to understanding its fundamentals. We have successfully covered the science of echolocation, the creatures which use it, and how echolocation is different within each creature. Echolocation is one of nature's most unique capabilities. It's a topic worth understanding and of much complexity. And I hope after today, you can go out into the world with a deeper knowledge and understanding of what's going on in our environments nocturnally when that light is off. Thank you.
Good.
Yes. Thank you.